Welcome back to Fix This Build That. Today we're going to be making a DIY steel fire pit and learning how to cut metal without using fancy tools.
And this fire pit is 2 foot by 2 foot at the top, and it's made from 1/8 inch steel, so it's sturdy, but still it's light enough to throw in your truck and take it along for a tailgate. I bought a 4 by 8 foot sheet of 1/8 inch plate steel along with some 3/4 inch square tube, and they sheared the plate into 3 32 by 48 inch sections for me at the steel yard so that I could move it by myself, because this stuff is heavy. I've always been a bit apprehensive about working with plate steel because I didn't know how to effectively cut it without some specialty tools. But I got the new Steel Demon blades from Diablo, the sponsor of today's video, and I was ready to give them a spin. They have a 7 1/4 inch blade that works in regular circular saws, and this sounded perfect. I marked the sheet to cut the sides for the firebowl, and then I set up a guide and made the cut with my circular saw. And being a novice at cutting metal, I made some mistake that you're going to want to avoid. I didn't have the blade lowered quite enough, I wasn't using enough downward pressure, and I was going too fast. Now together this made the blade come out of the cut and freewheel on top of the metal without me noticing it until I realized something was wrong. I butchered my way through the rest of the cut with this happening before calling for some help. I talked to some experienced folks and I was able to make some adjustments based on their feedback. They said for the best cut I should lower the blade to have one full tooth exposed under the cut, clamp my material down, put more even downward pressure on the saw, remove the 2x4s from under the cut line, and keep a moderate but not fast pace. So basically I was doing it all wrong. But these changes made all the difference, and when I made them I was cutting like butter now. Now the Steel Demon blades have Cermet teeth and they leave a burr-free finish. And I know it looks like there's a lot of sparks, but compared to a traditional abrasive blade it is much less. I'll have a link to all the Steel Demon products that I used in the build, and thanks to Diablo for sponsoring this video. I cut the straight sides and the bottom to width and to length, and I moved to the ends. Now the ends have a trapezoid shape to them, or is that a rhombus? I don't know, I should have probably paid more attention in 9th grade. But anyway, they're rectangles with 45-degree corners clipped off of them. I couldn't use my edge guide clamped at an angle, so I laid out the lines that I wanted to cut, and then I used a scrap of the plate steel clamped down parallel to the line to guide the saw. Now these cuts went pretty well, and I'll use the off-cut triangles later to make some standoffs for a grill insert. Now with the plate all cut down, I switched over to the legs. Now the leg design is pretty similar since it's also a rhombus, but then again Brad Pitt is also a Brad, and I'm not sure how similar we actually are. Well, anyway, I used my miter saw and a T-bevel to get a 37.5 degree angle, and I transferred it to my chop saw, which has a less exact mitering setup. I'm using the 14-inch version of the Diablo Steel Demon, and this thing is awesome. You can really tell the difference between an abrasive cutoff saw and this one. There are almost no sparks, and it cuts quick, and it's actually cool to the touch afterwards. Now, a slow-speed chop saw is a bit of a specialty tool, so you could also make these cuts in all the cuts shown today with a grinder and a cutoff wheel, and a little bit of patience. I cut the top connector of each leg assembly first with 37.5 degree angles on each end. The legs have the same 37.5 degree angle on the top to give a 15-degree splay on the legs to the side. So I cut the 4 sections of the legs with the angle I already had set up, but I had left them a bit long. I switched the miter fence over for the new angle, and then I cut my first leg. Then before unclamping the piece, I grabbed a couple 2x4s and I screwed them together. I used the top board like a stop block and I clamped it down to the table. Now I could put the other 3 pieces into the chop saw, butt them up against the stop block, and then get a repeated cut and a level fire pit in the end. And hey, if you're not subscribed already, and you really dig rhombuses or rhombi, go ahead and hit that button. Now the last pieces I needed were the lower connectors. I cut another 15-degree angle on a piece of square tube, and then I brought it over to mock up. It's always better to go ahead and mark the actual fit you want versus going off the drawings and measurements for a piece like this. I made the cut, and then I repeated the old stop block trick and cut one for the other side to complete the look. Now before getting into welding, I needed to clean up all the parts so that I had good surfaces to weld on. But first I wanted to cut down those triangle offcuts from earlier. I used a cutoff wheel in my grinder and I split the triangle into 2, and then I repeated that twice more until I had these small little triangles which I'll use to raise up the grill insert later. I switched over from the cutoff wheel to a 60 grit flap disc, and I beveled the edges of all the square tube. This gives the welding filler material a place to go and make that connection between the parts, and also having clean metal is the easiest to weld on. Now, all the edges of the plate that would be welded also got a good beveling, and I was ready to start throwing some sparks back inside. I used one of the extra 32-inch sections of plate steel on top of my outfeed table for the welding. It made a great welding surface, though clamping could have been a little bit better. I'm using the new Lincoln Electric PowerMig 140 MP today, and it's an easy-to-use multi-process machine, and it's got an entry-level price point. I'm going with shielded gas MIG welding, but it'll also do flux core, TIG, and stick welding. It runs off standard 120 volts, so it's a perfect machine to start with. I'll have a link below in the description to it as well, and you can check it out. I started off the leg assemblies, and I tack welded them at each joint, and then I came back and welded each seam. Now this includes the top and the bottom of each joint, so that they're completely sealed. Now, after I welded both leg assemblies, I moved on to the fireball. I laid a straight side on the table, and then I used these multi-angle magnets to hold one end in place while I tacked it together. I repeated this with the other end, and then I flipped the bowl upright to attach the other side. It was a little tricky to get the other side in place, but after some maneuvering, I got the magnets where I needed them, and I tacked the top in place on each side. Then I could pull the lower portion of the side into place to make it flush with the ends. I wanted to make this as flush as possible since it's the outside show face. I'm going to be doing all the welding on the internal seams, and I was able to keep this joint smooth for a nice clean look. The last part to add in was the bottom, and I'd have a decent looking fireball going on. I tacked it into place on the ends and the sides before getting into the heavy welding. I definitely didn't need to weld the entire length of each seam, but I wanted to practice, so I set out in short spurts. Now, one thing I quickly realized was that welding on a diagonal here on the sides was way harder, and my welds looked horrible. So I flipped the fireball on its end, and that way I could weld the angled sides flat on the bench, and they came out way better this way. I finished up welding all the seams, and then I went outside to pay the price for my bad welds. Now first I started grinding the inner seams of the fireball with a rounded corner flap disc, but I quickly realized the welded joints just weren't big enough for it to work effectively. So I decided to just leave the other inner joints alone, which those were the better ones anyway. I rounded all the corners and the edges of the fireball, and then I ground down the welds on the leg assemblies as well. Now these are much easier to do since they're mainly flat joints, and I just left the inside welds alone. I brought the pieces back inside, and I turned the fireball upside down. Then I put 2 scrap blocks next to it to prop up the legs where I wanted them. I clamped them to the bowl, and I measured for 2 lower stretchers to give the base some extra rigidity. To get the 2 stretchers exactly the same size, I cut one piece long, and then I made a mark on it for the final length. Then I scissored it up flush with another square tube piece and cut both of them to size at the same time. Now here again, I used the magnets to hold the work still, and I propped the stretchers up on some wood to tack them in place. Then I welded around each joint to finish off the connection and ground the seams flat outside. Now the base was an extra tight fit when I started to put it onto the fireball, but I knocked it into place and I centered it up using those standoff blocks from earlier to prop it up. I only welded the underside of the top of the legs so that I could keep that top connection looking as clean as possible, but it is plenty sturdy with just these welds. With the fire pit rough assembled, I needed to do some more work inside the fireball for drainage and airflow. I drilled holes in each corner of the bowl to allow water to drain out if it does get out in the rain. Then I came back and I grabbed those little triangles that I had cut to size before. I thought of a few different ways to make a grill insert to raise the wood off the bottom for a cleaner burn, but using these triangles seemed the easiest, and it's a great use of scrap that I already had on hand. I welded these little triangles in place just off of each corner and put another set in the middle. And I used the 45-degree slope of the sides of the triangle to match with the sides of the fireball and give a nice flat surface for the grill to sit on. For the grill insert, I bought some 1/4-inch round rod in 3-foot sections. I cut 4 pieces at 24 inches and another 9 pieces at 12 inches with my cutoff wheel in the grinder. I started off by laying out 2 24-inch pieces on the triangles, and then I put 2 12-inch pieces on the ends to make the outer frame of the grill insert. I tacked them together, and then I laid out the rest of the 12-inch pieces about 3 inches apart, and I filled in the inside, tacking them as I went along. Now to finish it off, I flipped the grill insert over, and I welded on 2 more 24-inch pieces. It makes a really nice grid to hold the wood up off the bottom, and it's removable so I can take it out and clean out the ash after every fire. I'm pretty happy with this design. The fire pit is right around 40 pounds, so it's portable to take out for tailgating or just to store it out of the rain when it's not in use. I left the steel raw because I really like the industrial look, and I'll see how it patinas with age. But I can always paint it later if it gets too rusty.
Hey, if you want to see some other projects I've done welding in, you can check it out right there. I've got a few more of them that I also incorporate woodworking. And if you want to see more metalworking, I'd love to know what you'd like to see. Comment down below and tell me what you think I should do next for some metalworking projects. Until next time, guys, get out there and build something awesome.